So I'm going to do the power test for these little lamps, and I'm going to do one on each as well. Not that I think there should be really any difference, but it would just be interesting to see, won't it? That there is a little bit of a difference between the betas on these transistors. The copper wire, and it's pretty much the same size, but there was more resistance in this than there was here, and there was more resistance, of course, in the one piece of wire than there is the two pieces of wire, because, well, with the one piece of wire there's only one channel, and with the two pieces of wire there's two channels, so you can actually, well, you know how that works with the resistances anyway when you put them in parallel and series, right? And, well, according to this, with the other piece of wire, which is exactly the same length, they're all exactly the same lengths, they're from the same wire, that has that amount of resistance, which again is not very much at all. So they're what I'm going to use to connect up to this, and then I'm going to connect these to the output of the amplifier, and then just take and then put the probes to the oscilloscope directly on to the connections here. So I'm going to set that up, heat the soldering iron and everything, and do that. Back in a minute. So I've soldered those wires on, and the resistance now is, as you can see, so it's still very low. We're still on 8 ohms technically, or, well, not technically, but for all intents and purposes we're on 8 ohms. Okay, so let's get this connected up, and I'm going to solder it onto these wires as well, just because we'll just make sure we get a good connection on the ground and a good connection on the output of this capacitor. And I know they're not the greatest input capacitors, you know, but I don't have any. I've used 4.7 microfarads here, and I don't have any 4.7. I've got one 2.2 film, which I suppose would be better, but then I would have unmatching, and at this minute in time they're matching. The only thing that's different between these is that capacitor is on at a slightly different angle to this one. This one's just twisted one hole to the right, my mistake, and this one's directly forward. I know that shouldn't really make any difference, but it won't make any difference to the sound or anything like that, but just on the, you know, them two being the same on slightly kind of different boards. I don't know why I'm rambling. I'll stop rambling. Let's get on with the test. Been using that generator over there to stick in the 1 kilohertz sine wave, and got some calculations off that. There's a whole bunch, so I'll go over that in a second. And then I decided to use this and found this nifty little piece of freeware. It's just called a tone generator. It's just a few kilobytes, the piece of software is, and put that in just to see if there's any difference. There's a very minor bit of difference, and you can take a look at that, and that's only on the FFT, you get to see that. But yeah, so basically we got all these like little calculations. Now what I've done here is I started off at 9.3 volts, and the reason why I did 9.3 volts is because when you get a 9-volt battery, it's higher than 9. You know, you don't get like a 9-volt battery. It's like 9.5, 9.6, isn't it? So I went for the middle, 9.3, and that's the current draw on the power supply at that voltage. And I just did a quick times those two together and got that. So, you know, we're using that amount of power to get this 1.16 RMS into the oscilloscope, and that gives us 0.1682 watts. And that's just on one channel, so 2 channels, you know, that times by 2. Now 12 volt, as you can see there, you probably already read it. Didn't bother doing the milliamp on the power supply, just oh sorry, yes I did. Look, I just didn't do the calculation there, but we got 2 volts RMS out of there, which is quite good. So we got half a watt per channel peaking before any type of clipping whatsoever. And then I did it at 14.3, and oh yes I did, that's alright. I was just looking for another one that I thought I should have done it at, but I didn't. And we got 2.49 RMS out of there. And the reason why I think this is best at 12 volts is one, because it's easier to have 12 volts supply, like if you use 12 volts AC transformer, and then you rectify it, put your capacitors on, so you've got your DC, you can have around about 17 volts, just under 17 volts, but then you're going to take out your 1.4 volts, 0.7 let's say for the two diodes, each cycle using two diodes of your rectifier. So you take that away from your 17 and then regulate that down. Remember to give yourself 3 volts for your regulator. So we're going to be playing around with like a little over 13 volts. And that's going to be the difference between what you're going to be using your 12 volts out your regulator and what you're actually going to be properly sort of supplying into the regulator once you take away the regulator voltage as well. Which is ideal, isn't it? 12 volts then, really. Maybe not ideal, you could probably tweak it a bit better than that, but that's okay. So you can expect to get a halfway decent signal out of that if I just turn it up to how far we can actually take that before it starts flipping out. And oh, wrong, because I'm not in the right thing for that. I want to turn that. We just get a little bit better idea of what that's doing. It's not quite as pointy, is it? So we can't really go up any further in voltage. We can drop down the input a little tiny bit until we decide that's probably about right. So if we say 2 volts, and we don't need really any heat sinking for that, because even though it does get a little tiny bit warm, it's nowhere near, you know, any type of heat that's going to cause us problems. And if you put a switch on this, which you probably would, power switch or something, or if you're clever enough you could probably do some sort of sensor so it knows when there's an input and it's on, and when there's no input it just disconnects the circuit. I'm not out of that stage yet, but I can see, you know, that it could be done. So yeah, 12 volts then. 12 volts is the way to run with this. I'm going to give you a little sound thing now at 12 volts, using it like this, and then connecting up to my laptop, and we'll see what we get. See what this sounds like in stereo, because we're going to have 2 channels. Because I've got this channel here as well. It's a complete matching channel, which you've probably already seen. This video is a bit of a mishmash and sort of forgetting which bits I've done and which bits I haven't. So you just have to bear with me if you see it all over again. Oh yeah, and just before I do that, I'm going to just quickly put this one on the scope and use the dummy load and feed it, and just see if there's any real difference on that particular channel as compared to this channel. It's all got exactly the same stuff on there, even down to the carbon resistor used there, as I used the carbon resistor there. That was actually the first one that I built, and that was the second one. Okay, so that's the other channel, and it's probably just as expected. It's set over there at 9. Take a look, we start to see it flatten out at the top first before it starts going at the bottom. It's not really that unequal either. It's not really that unequal, so let's take that down, get around about 2 volts. Yeah, it's pretty good. We're doing about the same sort of power. Maybe there's a few extra milliwatts on there, milliamps even. On there, but I'm not going to worry about that too much. I could connect it here, it doesn't make any difference. I had been doing that off camera just to see if there was any difference, and there's not. And as you saw, there's only like 0.6 or something milliohms in the wire, so not a great biggie there. So that's it then, that's all good, and really there's no difference on temperatures either on these. You know, it's even running it, I had it on yesterday. A lot of the day I did intend on going out and meeting some friends, but it was an outdoor thing we were doing and it was absolutely hooting it down with rain. So just played around with this, and had it going with music, nice. You know, don't get me wrong, it's not, well, as you know, it's only got like a half watt per channel really, without any sort of distortion or clipping. So you can't really expect it to be that loud, but it's funny. I don't know if it's because those speakers I got are like really sensitive or something, but this thing, it is loud. It's loud. You can't have it on like, you know, as loud as it will go without wanting to turn it down, because it's just too loud. I mean, that's pretty good, I think, for 1 watt peak overall RMS. So, but let's get it connected up to the speakers. So I've got a track here sort of like lined up. It's that, I don't know actually what it's called. It's called Motivate Sound. Sorry, it actually says what it's called up there, look. There you go, shout out to this chap. Let's have a little listen and see what it sounds like. I'm going to turn it up as well, because that's what we want, don't we? Try and see if my hands will stretch across my function, and to that, and it won't. So let me just try and do this a different way. I didn't think this through. Right, I'll have to do it like this. That's not as loud as what I had it with the Foo Fighters on, but I'm having to shout, and I don't know if you can actually hear me, but you get to see what it's using power. That's 2 channels, remember. So just turn up a bit more. Input power, so I can give it. It's on number 50 and it goes up to 100. Let's stop that. And if you remember now, this to get it to its peak output, the 2 volts RMS, it was using about 100 sort of, let's say 115 milliamp. It was a little bit higher than that, wasn't it? But let's just keep it under the peak. Now that's with both channels connected. What it's using there, so I'm just gonna, I like to play some sound through now. It's gonna start off like quiet. It's not terribly high, but this is just to show that like a nice gentle input of sound. So here we go. So you get to see how much it's actually using to try and work out, you know, what it was on the consumption of power from the power supply to what we were driving it at with the input signal. Not everyone's cup of tea the music, but it's not about the music. Okay, so I just want to just change the music a little bit, so you get to see there that it's not really pulling that much current, and I can't actually change it because I haven't set it up for any more music. Give me a tick. Okay, I've set it up to play that one that I played on the other video, because one, I didn't get any copyright notices, and it's a nice dynamic sound. So, and it's turned up, I think it's on my laptop here. It's if you want to see like, the song, yeah, and it's only like about number 30 or something on my laptop. So let's give it a go. Remember, I was trying to see how much power it's actually drawing to give a sort of impression of how hard we're pushing these things. Can get louder without any distortion, but I can't. That's the volume control with the function, and I can't. I know my hands are quite big, but I can't actually get them to spread that far. So let's see if I can cheat using this. I don't think I'm going to be able to, so. I'm just going to pause it. Do you know, if that's supposed to be half a watt per channel, well, it's definitely not a PMPO thing, is it? That's a pretty good half watt per channel. That's clean. It's certainly a room filling for sound, and that's not even drawing the amount of power when we were peaking it, you know, on the scope with the function generator, because we were sat at around 120 milliamps continuously. And that's peaking at about 120 milliamps between the two of them. So I reckon that's pretty good. I'm going to just try and turn it up a little tiny bit. So I'll just put that on. Get that. No, that's the enough thingy. Right. So I'll just get that. You can see that. Look, it says number 40 there before it goes away. So that's turned it up about another sort of 6 or 7. I think it was on 32, so. I have to pause it. Because that sounds lovely. It really does sound nice. It's probably because this track is quite nicely sounded. It's quite cleanly recorded. It's not a FLAC. It's not anything any good really. On the file size, I'll actually tell you what it is. It's the interlude tracks. If I do the properties down on there. And it's 8.36 megabytes MP3, but it doesn't tell me what the bit rate is. But I would say that, considering most tracks for this duration, well, that's quite a big duration actually. And most tracks are around about 4 minutes. On a CD are about 35 megs. Alright, so this is 8.36 megs, and it's just over 5.5 minutes long. So it's not a, you know, it's not a, probably it's a 320 then, possibly, or 192. It's going to be one out of them two anyway. It's not a 128 definitely. I won't bother downloading a 128. But that does sound nice. I'm not gonna, you know, sort of like push that any further. Should I just turn it up that a little bit more? We'll turn it up to number 50 on my laptop and see what it sounds like. I've got to do it with two hands. Cool. There we go. Look, number. Oh, I'll do that again. Go down one and go up one. Okay, there. Number 50. So let's do that. Watch your ears. It's going to be a bit noisier. I can do the subtle turn down actually, because I can just about squeeze my hands across there. I wonder if the Egyptians, you know, when they did their cubic and the hands measurements, I wonder if they actually had a specific hand size. It's almost as confusing as the amount of car lengths it takes to do braking at certain speeds when car lengths are all different sizes. But anyway, so there we go. There we go. I'm quite chuffed with that. I might actually build that up into a little case, like I said. There's so many little clips to this video. I don't know what's going to go in and what's not. But if I didn't say it or if I didn't put it in, I might build this into just a little plastic case. Do some volume controls, because I watched a pretty good video from John Audio Tech about setting up the volume controls for this type of little project. And yeah, and make another pair and give them to my grandsons for little MP3 players that we easy, cheap enough to pick up for them, some speakers, and blast their parents out in the bedrooms. By the time I got my own back on the kids. Right, cheers for watching, guys. You got this far. It's been a great little project. I'll tell you what, you know, I would say if anybody was thinking about building a little amp, this is ideal. Great little setup if you've got the parts to build them, you know, discreetly. So great little setup. I'm really chuffed with it. It certainly fills this room up, and I wouldn't be able to sit in this room and listen to that loud. Not unless I got a beer and I was having a little dance or something. I wouldn't just be able to sit in and work with it that loud. That's way too loud. But no distortion. Can't hear anything dodgy going on in there, and I wouldn't expect to either. So thanks for watching. See you in the next one.